So in this video, we're looking at trigonometric functions of any angle. So this is going to follow from what we did in the last video. So in the last section, we evaluated trigonometric functions of acute angles, like shown in the pictures below. So note that this angle is in standard position, and that point P at the coordinate xy is a point that's r units from the origin on the terminal side of theta. A right triangle is formed by drawing a line segment from our point perpendicular to our axis. So we can see we've got 4 different types of angles here based on which quadrant we're in and where they lie. So these are all in standard position, but they're not acute once we get out of quadrant 1. We can extend our definitions of the 6 trigonometric functions to include such angles as well as our quadrantal angles. So those are the ones that are on our axes. Oh, there we go. It tells us that, recall. So that point P could be any point on the terminal side of the angle other than the origin. So here's our definitions. Now these look a lot like the definitions you might see for the unit circle. They've still got the same x and y values at the same location, but notice that we are now including this, this r value. So that's our distance from 0, 0 to our coordinate. With the unit circle, we chose that on purpose because we liked it as a radius 1. So all of these, you'll notice with the unit circle, if our r is 1, we don't have a denominator anymore. That's why the unit circle is our favorite. So if we are at a different point where that distance to, think about a circle, right? If that radius isn't a value of 1, this is the formula that we're going to use. So r is going to be that distance from 0, 0 to our point, just like we see over here in our pictures here, because that's giving us the radius of a circle that would be created with that length of a ray. So same values, sine is with y, cosine is with x, tangent is y over x, but now we're having this idea of having to divide by r to represent the radius of the circle that would be created with the given ray. So because that point P on the terminal side, other than the origin, cannot be 0, we have to be careful, okay? As always, when you're working with fractions, the one thing you have to consider is domain. We can never, ever, 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 ever divide by 0. So we just have to be careful and be aware that those are the pieces that can't be 0 and make sure it works out that way. All right, so we've got some point P. It's the coordinate -3, -5. So I'm going to go ahead and just kind of sketch this out. So -3, -5 is going to exist somewhere down here. Maybe make it a little lower. Yeah. Somewhere down here. So if I were to consider that as my angle, right, and I draw my line perpendicular to my axis, this is the angle that I'm considering. So my x coordinate there was at -3, so that's my distance there. My y coordinate is at -5, so that's my distance there. And so we're going to find our 6 trig functions. So in order to do that, we do need to know the hypotenuse. That's that radius of the circle that we could create. So this is where we're going to use our Pythagorean theorem. So since that's the hypotenuse, we can go ahead and call it c. So we'll take our a, doesn't really matter which, squared plus our b squared is equal to c squared. And you'll find that c ends up being the square root of 34. So rather yucky radius. All right, so let's find sine. So sine of our angle is opposite -5 over hypotenuse of square root 34. So if you do rationalize the denominator, you just end up with this. Cosine of theta is adjacent, so -3 over hypotenuse square root 34. Again, rationalizing the denominator. Tangent is opposite over adjacent. So we have -5 over -3, which then becomes +5 over +3. To come up with their pairs, we're just going to take the reciprocal. So cosecant of theta, this is where I'm going to start with before I rationalized, because I don't need to at this point, because my square root is going to be in the numerator. So root 34 over -5. Secant of theta, we flip it, we get root 34 over -3. And cotangent of theta, we flip it, and we get 3 over 5. So we're going to do the 4 quadrantal angles. So As we think about this, I want to remind you of what was in the last section. If you didn't watch it, this is might be a new thing. So trig functions come from ratios. It's always that side over another side. And so it really doesn't matter how big your triangle is, how long your sides are. When you do that ratio, they're always going to reduce to the same amount. So trig functions only depend on the angle itself and not on the lengths of the sides. So you'll notice with these, they're just giving us the angle. So we don't know anything about the side lengths of the triangles that might be created. So because we don't know anything about that, we kind of get to make it up. And of course, we want to make things easy on ourselves, right? So because it only depends on the angle and not the side length, we may as well let our R value be a value of 1. So that way, just like with our unit circle, those denominators are going to go away, right? So we're going to say that our radius on any circle that would be created has a value of 1 to make things easy for ourselves. Okay, so we're only needing to do sine and tangent. Let's go ahead. I'm going to sketch a quick graph of my drawing, right? So to make things easy on myself, right, if my angle is 0 degrees and I want my R to be 1, I may as well put it there then at 1, 0. Again, making life easy on myself. So sine of my angle, if our R is 1, just like with our unit circle, we're not going to need to do any dividing, or we'd be dividing by 1. So our y coordinate here is 0. So I'd be dividing that by 1, but I just get 0 back. Tangent is y over x, sine over cosine. So that would also be 0 over 1, which is just 0. With b, our 90 degrees, or pi over 2, same idea. If my side lengths don't matter, I may as well put it up here at 1, 0. And my sine is my y coordinate of, 0, 1. Didn't move horizontally, it moved vertically. 0, 1. My y value is 1, and I said my radius was 1. So my sine of theta, let's name these thetas, right? That one's 0. This is pi over 2. So sine of pi over 2 then would be 1. Tangent of pi over 2 is y over x, sine over cosine. So we get 1 over 0, which would be undefined. All right, C, 180 degrees, or pi. So that's over here at -1, 0. So sine of pi. Again, we're going to take the y coordinate 0 divided by our r, which is 1, to get 0. Tangent. We're going to take y over x, so 0 over -1, which would also get us to 0. The last one is going to be 270 degrees, or 3 pi over 2. So that'll be down here at 0, -1. So sine of 3 pi over 2 is our y coordinate, -1 over r, which is 1. So it has a value of -1. And tangent, we take y over x. So once again, we would be undefined. So hopefully you're noticing some patterns, right? 0, 1, 0, -1, 0, undefined, 0, undefined patterns. Okay. The last thing to talk about is the signs of the trigonometric functions. So in that example, we focused on the quadrantal angles. However, we are going to return to the idea of what's happening in the quadrants themselves. So if theta is not a quadrantal angle, the sign depends on the quadrant that theta lies in. So in all 4 quadrants, r is positive. R is representing the radius, which is a distance, and distances have to be positive. However, x and y can be positive or negative. So we've got this chart here that represents the signs of the trigonometric functions. So in quadrant 1, all of our functions are positive. All 6 are positive. In quadrant 2, sine and its buddy cosecant are positive. In quadrant 3, tangent and cotangent. And in quadrant 4, cosine and secant are positive. So there's kind of a way to help us remember that. We use kind of an acronym. So ASTC. So the book here says their way to remember is a smart trig class. So in quadrant 1, all of them are positive. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. I use with my calculus students, all students take calculus, but then I've also heard a silly one, all snakes tickle children. So whichever method helps you remember is fine, but remember always going counterclockwise so that we're staying in that positive direction, but ASTC, and it tells you which trig functions are positive in which quadrant. So we're going to figure out which quadrant our angle lies in. So if tangent is less than 0, so tangent's going to be negative. So tangent is negative in quadrants 2 and 4. And cosine of theta is positive. So cosine is positive in quadrant 1 and 4. If we're trying to figure out which angle it lies in, we need to see where is the overlap. So that's in quadrant 4. I'll be good and do my Roman numerals there, quadrant 4. All right, last one here. We're given that tangent of theta is negative 2/3 and that cosine is greater than 0. So we're supposed to then find cosine and cosecant. So notice here tangent's negative. So again, tangent is negative in quadrants 2 and 4. And cosine's positive, so that's in quadrants 1 and 4. So once again, we're talking this angle has to be in quadrant 4. So when we think about quadrant 4, down here at the bottom, we know that cosine is positive. So that's our x value is positive. So that means if this is tangent is sine over cosine, or y over x, that means x has to be positive, which means the negative goes with our y value, which should make sense in that quadrant of 4. Our x value is at a positive 3, and our y value is at a negative 2. So drawing that in, we've got negative 2 and a positive 3. We've got our angle there. We're supposed to find cosine. Well, again, we need to find that r value. We need to know the hypotenuse. So we can use our Pythagorean theorem. Negative 2 squared plus 3 squared is, we'll go ahead and just call it c squared. And what do we get? We get square root 13. So cosine of theta is going to be adjacent 3 over hypotenuse of square root of 13. So if you rationalize, you get 3 root 13 over 13. Cosecant is the reciprocal of sine. So I'm actually going to find sine first. So if I find sine of theta, sine is opposite, so that'd be our negative 2. Oops, going too far, sorry. Negative 2 over square root 13, but I don't need to rationalize here because, again, I'm actually finding cosecant. So I just need to flip it. Cosecant of theta is going to be square root 13 over negative 2.